They have my photograph as well.
Wow.
So I'm next to George Bernard Shaw, the playwright.
That's incredible.
I should have taken the camera and shown you the gallery. So this is anyway, it's an interesting hotel. Can you see me against the background
Your
of the ocean?
your face has a little bit of a glare from the sun, but I can see you. Just your
Okay.
face is a little blurry from the sun.
Okay, let me just connect. How should I do it? Is it better this way? Is it better? No?
It's about the same, but it don't matter.
Let me
It's
go
fine.
inside. I thought if you can see the sea outside the window, that'd be good. But can you see anything behind me?
Just the sun. It's like white. It's a white
Oh
window. It's
no,
like
that's not good
yeah,
enough. It's not good enough. So let
yeah.
me
But
let me go to a different place and in the same room and see what's any better.
oh yeah, that's a good angle.
That's better, isn't it?
Yeah, you'll be able to see you from there.
Is that better?
Yep, that's perfect. Yeah, it's very good to see you.
Okay. Yeah, it's nice seeing. It's okay. You can have me to adjust the furniture a bit because my friend over there is finding how is the lighting now? Is it okay?
Perfect.
Perfect. Okay.
You look
So you
great.
don't see unfortunately, you don't see the great Indian Ocean behind me, but
I
it is
know
there, and quite an imposing ocean it is.
that it is. That it is. And what a great it's really remarkable how and well deserving how Sri Lanka treats you. It's really incredible.
And, uh,
It's a pleasure to have you on always and to spend some time to you. Let's everybody for those joining us on YouTube, we're going live now. Well, yeah, all right, we're live on YouTube now. This is the Space Water Podcast, episode 66, and it's my pleasure to have on our longtime friend and colleague of the show, Professor Chandra Wickramasinghe. Now, Professor is one of the men responsible for the name of astrobiology with his mentor, Fred Hoyle. He has so many books on the subject, which was just a theory many, many decades ago, and now it has been proven all these years later that his hard work has finally paid off and is being recognized all over the world. Professor Chandra, it's always a pleasure to have you on the Space Water Podcast, and it's an honor to always see you, and it's a pleasure to see you as well.
Thank you very much. Thank you for having me. I enjoy talking to my friend Ra, and it's great to be talking to you from a rather strange place. I normally speak from my home in the United Kingdom, and now I'm in Sri Lanka, which was the place of my birth, and I'm here in a hotel that is 150 years old, and it's an iconic hotel in South Asia. So anyway, that's where I am at the moment, and I'm overlooking, you can't see this from your screen, but I'm overlooking the great Indian Ocean, right? And the oceans of the Earth were surely laid down by the impacts of comets. No question about it. When the Earth formed 4.4 billion years ago, it was just a rocky mass of rocks, hot, molten rocks. And with the passage of time, comets began to hit the surface of this molten rocky planet and eventually produce the this Earth that we see with oceans and so on. And so it's great to be here in front of the oceans that were essentially brought originally by comet impacts. And I guess, Rob, you're going to talk about comets, right?
Yeah, that was one of the main things I would like to talk about, and probably the only thing. I mean, and for those that don't know out there, I'm sure Professor Chandra has probably even written about this. Even a Roman emperor had a temple for a comet. After Julius Caesar, I think, was died in like 44 BC, they had a temple for the comet star in Rome, and they were always held significant and had to do with birth and rebirth and life on the planet. I think in ancient times they understood the importance of comets even
Yeah, in
before.
every
Yeah.
culture, right across from Japan, China, India, Sri Lanka, and so on, comets were both revered and feared. They were revered because they were thought to bring good things to the earth, and they certainly bring good things because they brought life to the earth. But they also thought that comets were the cause of disasters. Collisions of comets caused destruction of cities, and stuff coming down from comets, according to my work with Fred Howell, and a theory is a theory still, brought also epidemic diseases that wiped out large populations. So comets have a really powerful if influence on human history.
Yeah, I totally agree. Now, what I wanted to get into today is a very interesting discovery. I think the largest comet ever discovered to this date, if I'm not mistaken, Professor
Well, I
Chandra.
think, yeah, pretty close to being the largest. I mean, it's very difficult to gauge the size of a comet from astronomical observations. So it's hard to be sure, but this is certainly a very large comet. And the great interest in this comet, I think, the hype over the comet is that it's not part of our solar system. It's coming from the depths of interstellar space. And such comets are relatively rare. They're not rare, really, over historical timescales. There have been many, very many of these comets. They're not as common as the sort of homebrewed comets from the so-called Oort cloud that surrounds our planetary system. But they do come from time to time. They do come from very far away and I think they come from other solar systems, other planetary systems, and they just whiz past us, maybe close to the Earth sometimes not so close to the Earth, and goes back to distant space, to interstellar space.
Other
I
Oort
think,
clouds, even, right?
was it?
Possibly other Oort clouds.
Possibly other Oort clouds. I think to think that our Oort cloud is unique to our solar system is just crazy. I think there's no way in which it could be true. So every planetary system, and we know that there are millions of planetary systems now. From 2009 onwards, there was this great Kepler satellite, Kepler telescope, orbiting telescope, that was essentially devoted dedicated to for discovering exoplanets, planets outside of our solar system. So thousands, tens of thousands of these planets have been discovered to date. Uh, so these are I think planetary systems are very common, and by inference, comets must surround all these planetary systems because they have to be generally, I mean, not identical, generally similar to our solar system, our own planetary system. So occasionally, comets from a distant Oort cloud or distant comet cloud escapes that planetary system and finds its way whizzing through our own nearby to our planets. And that's what happened with Atlas a few days ago. People are making a big fuss about it, but wasn't the first time. There was Oumuamua, which was also a hyperbolic, as they
Yeah.
called it, hyperbolic comet, came from outside of our solar system.
Atlas is
And
number three, right?
yeah, yeah. So it's not the
Now, before we talk about more about the Bernardinelli, Bernstein, the biggest comet we were talking about, that one you brought up, Atlas. Let's talk about that for just a second, if you will. And I don't want to criticize any of your colleagues because I've seen Avi Loeb discussing that he thinks it's an alien probe, but I
oh
really
no,
don't see any. I don't really don't see any evidence
no
to that.
me.
I mean, I would
I
love for it to be.
Yeah, I would love for it to be. I think that'd be very romantic to have
Yeah,
a bit of a intelligent craft whizzing through. But I think at the moment, all the work that we did and myself and my collaborators did don't substantiate, don't back up that claim. It is another comet, the comet that came from far away out from outside the solar system. It came and went and deposited lots of debris in the form of a tail. Perhaps the Earth and some other planets maybe will mop up that debris in the course of time, perhaps not. And so that's it. I mean, this is one of the Oumuamua and the new Comet Atlas are just rarer events.
yeah.
They're not as common as Oort cloud comets, but they do happen. So it's not a big deal, really. But I think what the big deal is, Ra, it shows that comets that carry life from, we think that comets, and we've written extensively about it, we think that comets are the carriers of life, are the transmitters of life, transporters of life, are the incubators of life, right? And if incubators of life from a very distant planet is just throwing their stuff in our own backyard, then we must pick it up sometime, right? We say our people on the earth, our humans on the earth, life on the earth must pick it up. And so that's been the story of my work with Fred. We said that the whole of the galaxy is one single connected biosphere, okay? So genes from distant systems are exchanged or introduced into our system. And this is the main mechanism for evolution of life on Earth. I mean, Darwinian processes occur, but they occur only as a fine-tuning process, right? Birds with longer beaks and so on, all that kind of stuff does happen. So there is natural selection, breeding selection, but the overwhelming story of life on Earth are sudden jumps, very, very discrete jumps, from single-celled to multi-celled to insects, to winged insects, to plants, animals, and so on. So it's a stepwise process. And one of the great, biggest events in this story of life developing on Earth was the so-called Cambrian explosion, the explosion of multi-celled life, many life with many cells, fish, and so on, and it all happened very suddenly. And I think the arguments for a comet impact or a series of comet impacts, bringing this new genetic material, like maybe from comets like Comet Atlas, who knows, led to this great surge of multicell life. And you and I and Castaldo and Chandra Wickramasinghe are part of that inheritance.
Yeah, yeah, that's incredible. I mean, what is your colleague Avi Loeb? I didn't really watch any of his videos, but what's the evidence? Did you know what the evidence? Because is it? I'm guessing what he was speculating that made him think that. Is it because the Atlas and Oumuamua kind of like had nearby approaches to certain planets?
Yeah, well, it's not that nearby. I mean, it came within the
Yeah,
inner
not
soul.
that nearby, but it seemed like it went close to,
Yeah, it went through, it sort of skimmed the inner
certain
solar
path.
system.
Yeah.
Yeah, yeah. And so that's necessarily, it means that stuff from that comet was sort of sprayed into our vicinity, right? Sooner or later, the Earth would pick up stuff from, I think, maybe from Comet Atlas, maybe from Oumuamua, maybe from many other hyperbolic comets that came from very, very far away. And what that means is that evolution from on our point of view, that evolution is connected across the entire galaxy.
And this happens, the stuff that we're talking about that comes out, it happens from like outgassing and all sorts of
Yeah,
things.
outgassing. Comet, typically when it comes past the sun or when it comes close enough to the central part of our solar system, begins to develop these long tails, right? And the long tails are just outgassing, stuff being thrown out through maybe just evaporation processes plus internal processes within the comet that sort of boiling off of material, basically. So that happens, and that's well documented, and that's why we have comets with long tails and the whole story of comets being dragons, right?
Yeah.
Chinese dragon is a comet.
Yeah, I'm very interested in that. See, I know that magnetic reconnection plays a part in the universe in the cosmos in different ways. Like I know it happens on coronal mass ejections, it happens in
Mm.
the magnetosphere. But how much does magnetic reconnection take a part in the outgassing of tails of
No,
cometary?
it wouldn't play much of a part because these are the outgassing, the outgassing that leads to this visible tail are dust particles or particles of bacteria, which I like to think they are, and they are of sizes that are not. They're not a plasma, as it were. They were just particles that have been driven out
Oh,
by the pressure of radiation.
but there is plasma in the tail there, right?
There's plasma in the tail there, yeah.
And that plasma it there is no but is there magnetic reconnection taking place in the cometary tail?
Magnetic reconnection. No, I mean, there's very little evidence of internal magnetism in the comet, but the particles are almost invariably charged, electrically charged, because they're exposed to sunlight, and the sunlight throws out electrons from the surface, right? In most materials, so you get a charged particle, and the charged particle then interacts with the magnetic configuration of the Earth, of the sun. The sun has a magnetic field at magnetosphere, and
Yeah.
it exists all over. So there's a instant connection between the magnetosphere of the sun, magnetospheres of the inner solar system, and the charged particles that are being introduced from outside.
Yeah, I was thinking about like when the solar wind interacts with the yeah, yeah.
Mm.
Well, that's interesting because like the Bernardinelli Bernstein comet is outgassing even while it's very far from the sun.
Oh yeah, I mean that according to standard comet ideas, that's a mystery.
Yeah.
How can a comet that is so far away, so cold at the surface, right, um, produce outgassing at that rate? And it
Yeah.
just shows that biology has been active. There have been huge pools, subsurface pools of liquid material full of bacteria, full of living organisms, and they are just producing gases, and the gases accumulate under the frozen crust of the comet, and eventually, at some point, the crust gives way under pressure from the gas that is produced by the bacteria. I mean, we've had that on so many comets, I think, and written about it, and nobody seems to take much notice of it. But that's the only way in which one can have
Yeah.
comet activity at large heliocentric distances, at
Wow.
large distances from the sun. And
Yeah.
there's many comets now that have shown this. I mean, there's comet Lovejoy, a very interesting name, right? And it produces not just the tail of dust in the cold depths of space. It produces ethyl alcohol and a sugar,
Wow.
right? And that's the way that wine and so on is made. So it's a comet full of delicious stuff.
I love the way I love the way you said
I,
that.
I
Yeah, it's
I wish I had my glass of wine to show you. But
yeah. It's delicious. That's amazing. So, uh yeah, I mean that comet is yeah, it's a mystery. I can't like it's amazing how it could be outgassed. And I thought it directly had to do with the solar wind. So if it's
no. Solar
yeah,
wind could sort of push around the outgas stream, but the outgassing itself is caused by internal forces within the comet. It's a
that's
buildup of
incredible.
pressure, buildup of pressure under a frozen crust. If you build too much pressure up under a relatively thin crust, then the crust breaks, the crust cracks, and the gas gushes out.
Yeah.
Gas and dust and the bacteria and everything gushes out. And that's what happens in all comets. And this is what we've written about for donkey's years, and no one is taking any notice of it because they think that comets are dead objects,
Yeah.
right? So much so that, I mean, this is a really very
Horrible.
interesting story. About a year ago, there was a great hype amongst astronomers who think they detected uh, dimethyl sulfide in an exoplanet, right? Hundreds of light years away. Okay? You're with me? And
Yeah.
what they found was that this molecule is probably only produced on the Earth by living organisms. So what was the inference they made? They said that this planet, the icy planet, many, many hundreds of light years away, is a living planet. Right? There is biology there. But that really raised a question because how does the biology get there? Is it a primordial soup happening all over again
Yeah.
against the odds? Or is it panspermia? They had the word panspermia, so they've been trying to degrade that discovery as much as possible. But now listen for it. Recently, some months ago, they discovered, another group of astronomers discovered dimethyl sulfide in the comet that was studied in the Rosetta mission, right? Comet 67P CG is it called. And they found that that comet had evidence of dimethyl sulfide. So immediately, of course, they said this is a great concern for us because comets are dead. How can they have dimethyl sulfide? So dimethyl sulfide, therefore, instantly was degraded from a biological molecule to just a molecule that might have formed randomly. So this is the perverse nature of astronomical activity at the moment. Is if they find anything, any comet that has signs of life, that has to be discarded.
Yeah, it's horrible. I hate the way the science is, and it becomes dogmatic too. So with the comet Bernardinelli Bernstein that we were talking about, well, from what I was reading, that it changed its direction over 2 million years ago. Does that mean that
Mhm.
something affected its orbit? Like something had to change of its orbit somehow, or there was an
Yeah, well,
event?
I don't know. It's not very clear what happened to it, but it certainly was a hyperbolic comet. It's a comet in the solar system now. It's a bound comet, right? Whether it came from outside and became bound in our solar system is an open question. So I don't think that's an important question, but it has had a history that is somewhat mysterious.
Yeah. Let me pull up what you sent me. The slides. Here we go. Um, there we go. Here's the slides that you sent me.
Yeah, I mean, this was, I think, it's a real photograph of the comet in September 2021, when it was so far away that there should have been no visible activity in the comet. We shouldn't have been seeing the comet according to conventional comet theories, right? But we saw the comet, which means that the comet in the dim, distant regions of the solar system was already active, was throwing out material, and that material was reflecting the light from the sun. So this is you can see that in the horizon, the streak of it was quite a major event. I didn't see it myself in Britain, but it was seen by many, many people. This is Atlas, of course. No, that's not
Yeah,
Bern.
Here's Bernardinelli Bernstein right here.
Yeah, yeah, yeah. Okay.
Bernardinelli
Yeah,
Bernstein.
yeah. So Atlas is just another. I mean, people are making a big fuss about it, but it's just another hyperbolic comet, and thousands of hyperbolic comets have been recorded over the last 100 or 200 years.
So the three that we've discovered is just sort of like three that since we've been looking kind of, right? Like there's
Yeah,
probably been
yeah,
other.
yeah. Since we're looking and since yeah, if you see a comet coming at very high speed, darting through the inner solar system, heading back into interstellar space rather than into the outer Oort cloud, then we get very excited and we think um, that it's a special event, but it's not such a special event because if all of these other planets, and there are some, perhaps millions or billions of planetary systems with Oort clouds around them, and if that is the case, then there has to be a loss rate, evaporation rate from each one of these, right? So comets at the periphery of these Oort clouds of these other systems have to be getting out of their systems, and they'll be darting through interstellar space. And so these few comets that are being talked about now are just a handful.
It's interesting that I like what you sent me here with the Burkle crater, Professor
Oh
Chandra.
yeah, I sent it to you because here I'm in Sri Lanka and
Yeah,
overlooking the Indian Ocean and
yeah.
5 miles south of the Indian Ocean. And this was discovered, what, about less than 30 or 40 years ago, under
And
the sea, some few hundred miles, maybe 1,000 miles south of where I am at the moment, southern coast of Sri Lanka, is a huge crater in the ocean floor, right? And so there was an impact of a comet, we think, and the splashback from that impact is seen in parts of Africa, the African coast, and certainly in Australia. They've been recovered. Okay, so this is an impact that threw out a lot of material, and the story has it that it was the impact. This is 5,000 years ago, right? It was the impact that caused the flood story, the biblical flood story, right? That happened perhaps roughly at the same time, and as a result of the Burkle comet impact. Not only
that's what I was
that,
going to ask you. I was going to ask you that, and even the way it's, where it is in on the on in the earth, a lot of the biblical flood stories talk about, a Noah's Ark or some sort of ark being deposited in the hills of Ararat and
yeah,
Turkey.
yeah. Yeah, yeah, yeah. All that
Um,
fits the impact, the comet impact idea. And what I found interesting, because we're here. This is the country of my birth, and my ancestry is all in this location where I'm sitting now in Sri Lanka. And the story is that 5,000 years ago, Sri Lanka was completely submerged. There was no island. It was under the water for a good 500 years, perhaps, or even more. And it emerged from the ocean, and all the mythology of South India and Sri Lanka have versions of this story, an island emerging from the water. So that's been my interest. My personal interest is because of the connection with Sri Lanka, but it's also interesting because it was a major comet impact of the on the scale of the KT extinction impact, right? The extinction of the dinosaurs took place as a result of a huge comet impact, and the impact crater for that has been discovered, well, 20 years ago in the Yucatan Peninsula, right? There's a huge crater that has been dated at precisely 65 million years ago. So impacts of that kind of comets have been sporadic throughout the history of the Earth, throughout geological history.
it's very interesting. I love it. It's one of my favorite topics to talk about. Now, you also have in India, above from Sri Lanka, the Deccan Traps, which is like a huge area of a basalt event that
Yeah,
I guess was from volcanism. But what do you think triggered the volcanism on the planet? Do
I
you
think
think?
volcanism was is in that case was also undoubtedly triggered by an episode of impacts.
Wow.
Episodes of impacts are generally neglected because the evidence is not strong for the. I mean, if there's a huge crater like the Berkeley crater, then the evidence is there. It's incontrovertible. But if there's a shower of small impacts, then that is not so easy to maybe be very sure about. So I think it's the whole impact events that cause these
Yeah.
events. I mean, the Tunguska crater,
Yeah.
that was a comet impact that destroyed forests for
And no crater.
no crater.
Yeah.
No, the comet exploded in the upper atmosphere. The explosion was enough to cause the damage that was done. And then, but there would have been many such comets which did not reach the Earth, but which blew up cities from time to time.
Live in the Hudson Valley in New York, we have the Palisades Cliffs, like these basalt cliffs. And I always
Yes.
wondered if that was an event that was originally from comet impacts or some sort of meteor impacts or something.
Yeah, yeah, it could well be.
Very interesting. Very interesting, Professor Chandra. I really appreciate you coming on and spending some time out of your busy schedule. You're, over in Sri Lanka. Uh, and I really appreciate. I know you had an injury you were nursing and getting better from as well.
Well, yeah, and I had a knee injury, which delayed my trip to Sri Lanka by 2 weeks. I'm still a bit sore in my right knee, but I think it's getting better.
Well, I
Um,
wish you the best, and I hope everything gets better for you very quickly. And it's always a pleasure to have you on and spend some time with you. I look forward to you coming back on, and so hopefully.
Thank you.
Thank you so much, Professor Chandra. Everybody, this is the Space Water Podcast, episode 66. Professor Chandra, we were discussing the Bernardinelli, the Bernstein comet, one of the largest comets ever discovered. And I really appreciate everybody joining us so early in the morning here. And welcome to the Space Water Podcast.
Thank you. Okay, send me a link to it when you've